In this class, we're going to discuss kind of an introduction to arrays. So what is an array? Well, an array is a data structure that can hold multiple values of a single type. If you needed to hold one type of value in your application, you could just declare a variable. And if you needed to hold two values in your application, you could create two variables. But what happens if you need to hold 10,000 values in your application? It is not practical to declare 10,000 discrete variables. So in this case, we can create one structure, one variable, that holds 10,000 values. And that's what an array is. Arrays have a fixed size. So once you create one of these array data structures of a certain size, that size cannot be modified. You can't add additional elements or subtract elements from the array. Data in arrays are accessed by index, and we'll talk about that in a moment. While data can be accessed one at a time, often arrays are used. When you use arrays, you want to access all the values in an array, or a big chunk or subset of the values in an array. So arrays and counter-controlled loops go hand in hand very frequently. And then finally, an analogy of an array is like a bookshelf. So let's say I want to store, if you think of the books as data, if I want to store a whole bunch of books somewhere, I can build a bookshelf. And the bookshelf will have a specific size, and a bookshelf will hold a certain number of books. And if I wanted to add additional books, once I filled my bookshelf, I would either have to create a new, bigger bookshelf. Well, that's what I'd have to do, create a bigger bookshelf. All right. The syntax to declare an array is as follows. First thing we are going to do is define the array data type. You define an array data type by taking any data type and pairing it with a pair of square brackets. So you can create an array of any data type, any object type, anything. Then we are going to give our array variable an identifier so that we can reference it. So that defines the variable that holds or references the array. Next thing we need to do is build the array. In C#, our building keyword is new. So the new keyword is a building keyword. It says we are about to build something. So I'm going to assign into this this array identifier, I'm going to create a new array of that same type of array. So I'm going to have my data type in square brackets again. And in this case, inside the square brackets, I'm going to have the size of the array. How many elements will it hold? And it's going to be some integer value. So let's look at a couple examples here. Declare a string array that will hold 10 strings. Well, our data type for our array is a string array. These two square brackets, when paired with a data type, make it an array of that data type. Then I'm naming my first array, array1. And then I'm going to build this array that will hold 10 strings. So I'm building a new string array that holds 10 items, 10 values. Let's look at another example. Declare an integer array that will hold 109 int values. So my data type is going to be an int array, so integer in a pair of square brackets. I read this as an integer array named array2, and then I'm going to build this array equals a new integer array of size 109. So we're building this shelf that will hold 109 integers. Then finally, create an array that will hold n double values. Let's say n is some variable that's declared above. Maybe the user is inputting a value and we're storing it in n. The point is, you can create an arrays based on a size that is variable. So here I'm going to create a double array named array3, and when I build it, I'm going to build it to be whatever the size that n currently holds. All right, visualizing an array. So here I have a little graphic we'll walk through this graphic. So first I'm going to create an integer array that holds 10 integers. So here's my syntax to build the array. Integer array named myArray is equal to a new, I'm building it, I'm building an integer array that holds 10 items. And so this structure here represents this integer array. I have 10 locations, 10 spots for values inside the array. Now for me to access an individual spot in the array, I need to know its position or its index within the array data structure. The array name, myArray, is referring to the entire data structure, the entire bookshelf, for example. To get to an individual book on the bookshelf or an individual value on the bookshelf, I need to know its position. And we can find the position based on the index of the array. The index of the array always starts at 0 and then counts up by ones. The index always starts at 0 and we always know where it ends because it ends at whatever the array length or size is minus 1. Since we're counting starting at 0, the last index will always be 1 minus or the 1 less than the length of the array. Okay. So if I wanted to access, for example, this fourth indexed spot, I would access it using the array name, then a pair of square brackets, and the index within that array that I want to work with. So for example, if I had the line myArray at index 4 is equal to the value 13, I'm assigning the value 13 into the fourth index location in my array. So I stick the value 13 in here. Okay. Now how can we work with all the values in an array? Well, here I'm going to show us an example of how we can loop over an array or iterate over an array using the index. When we iterate over an array using the index, we can do both read and write type operations against each element in the array. So here I have a visualization of my array. I see I have all the indexes listed here. And here's my loop. This is a cookie cutter loop. It will always work to allow you to access all elements in an array. So we're going to say for, I'm going to create a counter variable that's going to start counting at 0, and it's going to count all the way up to, it's going to keep counting while that index value is less than the length of the array. Remember, our indexes start at 0, and our indexes are always going to be less than the length of the array. So if the length is 10, our last index will be 9. That's why I have a less than here. So I'm just counting up my indexes from 0 up until we get to the length of the array, and we're counting by ones. To access each individual index, I'm going to use the syntax, the array name, at the index I. And the way this works is when I is 0, I'm pointing to the first location in the array. Then when I is 1, I get the 1th location. And then I is 2, 2th location, and so on. So as my counter-controlled loop is moving down the index, I am accessing one at a time each location in the array. This allows me to read or write a value to each location in an array. So here we're going to show how we can iterate by value, or loop through the array by grabbing values. When we iterate by value, this is a read-only operation. I can only test against the values that are stored in the array. I cannot change them, and I will show you why. Here I have a graphical representation of my array, and this time I put some dummy values into it. And notice I've hidden the indexes of the array, because when we iterate by value, we're not dealing with the indexes. We are just grabbing the raw values out of the array one at a time. So my loop to do this looks something like this. For each, I'm going to grab for each. This next part describes what is the data type that's stored in the array and what is a temporary variable name that I can use to store each individual value one at a time. So I'm just calling it val, but this could be x or y or anything you want. So for each integer value in my array name, so this is the name of the array, For each value in the array, what do I want to do? I want to do something, maybe test the value or print the value. I'm working with this value variable. So what goes into val? Well, the first time through this loop, I'm going to grab the first value, which is 9, stick it in my val variable, and then I can test against it. Then the next time, the next iteration through the loop, I'm going to grab the next value, which is 12, store it in my val variable, and then I can test against it. Then I will grab the next value, and the next value, and so on, until we have grabbed all the values in the array. So iterating by value allows you to grab all the values in the array one at a time, starting from the first, ending with the last. But because we are not grabbing the index, I cannot change this val. I can't say val is equal to 10 because the value is 9. It's just I can't assign one value to another. When we iterated by index, I'll go back a second. When we iterate by index, we are grabbing the location. So we can assign a new value to the location or test the current value in the location. But when we iterate by value, we can just read the raw value. In the next video, I'm going to do a short example using arrays.